Let's do question 1. Here we find the derivative of y equals 3 raised to the power of x power 4. So we can find its derivative using the u substitution. We are going to make the u substitution u equals x power 4. So we find the derivative of u with respect to x, that is du by dx, and this equals the derivative of x power 4. According to the power rule, it is 4x power 3. Now we can rewrite this y after making the substitution for x power 4 as u. So therefore this y becomes, we have y equals 3 raised to the power of, replace x power 4 by u, it becomes 3 power u. Now let's find the derivative of y with respect to x. So therefore we write dy by dx, and this equals, since this is a function of u, we find the derivative of 3 power u. For that, we use the derivative of a power x, which is given as a power x natural logarithm of a. Therefore, the derivative of 3 raised to the power of u, and this equals, according to this rule, 3 power u times natural logarithm of 3. So let's write that first. So this equals the derivative of 3 power u is 3 power u times the natural logarithm of 3, and then we have to apply the chain rule to find the derivative of u with respect to x, that is du by dx. Now let's replace u with the substitution that we have made. U equals x power 4, so replace u by x power 4. This becomes 3 raised to the power of x power 4 times natural logarithm of 3 times, we already found du by dx, which is 4x power 3. That is, I write down 4x cube. We can write this in simple form. This equals, I'm going to put this in front. So it will be 4x power 3 times, we have another term, that is 3x power 4, and then natural logarithm of 3. All three quantities are different, so we can include them in the brackets. So this is the derivative of y. We now do question 2. Here we have y equals e power 3x, and we find its derivative. So once again we make the u substitution, that is u equals 3x, and let's find the derivative of u with respect to x. So du by dx equals 3 times the derivative of x is 1, so it is basically 3. And we can rewrite this equation in terms of u. So therefore y equals e raised to the power of, replace 3x by u, so it becomes e power u. Now let's find the derivative of y with respect to x. So this is dy by dx, and this equals, since this is a function of u, we write down this, the derivative of e power u is e power u times, then apply the chain rule to find the derivative of u with respect to x, which is du by dx. So let's do the back substitution for u. U is 3x, so replace u by 3x, we get e power 3x, and also write down du by dx equals 3, so we multiply this by 3, and so therefore we can write this as 3 times of e raised to the power of 3x, and this is the derivative of y. Let's find the derivative of y equals 2 times e raised to the power of 3x power 5. So once again we make the u substitution. Here we make u equals 3x power 5, and so we can find its derivative, that is u prime, and this equals, we find the derivative of 3x power 5 using the power rule. So we put the 3 first, and the derivative of x power 5 is 5x power 4 using the power rule, and so therefore this becomes 3 times 5 is 15x power 4. Therefore the derivative of u with respect to x is 15x power 4. Now we can rewrite this equation for y in terms of u after we made the substitution. So this becomes y equals 2e raised to the power of, replace this 3x power 5 by u. And so therefore this becomes 2 times e power u. Now we find its derivative, that is dy by dx, and this equals, so we have this 2, the derivative of e power u is e power u, and then multiply this with the derivative of u, which is u prime. Let's substitute the value of u and u prime, and so this equals 2 e power, replace u by 3x power 5 times u prime is 15x power 4. So I substitute here. Now we can multiply this 15 with 2, which equals 30. And so this equals 30. I put this x power 4 in front. So it is 30 x power 4 e raised to the power of 3x power 5. And so this is the derivative of y. We now find the derivative of y equals e raised to the power of tan x. So here we make the u substitution, u equals tangent x, and this implies the derivative of u, which is u prime, and this equals the derivative of tangent x is secant squared x. So we write y in terms of u, that is y equals e raised to the power of, replace tangent x by u, it is e power u. Now let's find the derivative of y with respect to x, that is dy by dx equals the derivative of u, e power u is e power u, times we apply the chain rule to find the derivative of u, which is u prime. And so we can replace the u by tangent x. So this is e raised to the power of tangent x times u prime, which is secant squared x. And we can also rewrite this by writing the secant squared in front. So this one is secant squared x times e raised to the power of tangent x. And this is the derivative of y. We now find the derivative of y equals e raised to the power of root x. So here we make the substitution, u equals root x. So we have to find the derivative of u with respect to x. Before that, we can write this square root of x as x raised to the power of 1 by 2. Now we find du by dx, or the other notation for this one is u prime, and this equals, we apply the power rule to find the derivative of x power 1 by 2. So we put the 1 by 2 first, and then raise x to the power of 1 by 2 minus 1, and so this equals 1 by 2 x power 1 by 2 minus 1 is negative 1 by 2, and this can be written as a positive power of x, that is 1 by 2 times x raised to the power of positive half. We know that according to the exponent clause, x raised to the power of positive half is basically square root of x. So you can write this as 1 over 2 times of root x. So we found the derivative of u with respect to x is 1 over 2 root x. Now we will write this equation y in terms of u by replacing root x as u, because that's the substitution that we made. So this equation becomes y equals e raised to the power of u. So we can find its derivative, that is we are differentiating with respect to x. So dy by dx equals, we should apply the chain rule after differentiating e power u. The differentiation of e power u is e power u times the derivative of u prime. And so let's replace e power, we replace u by root x. So this becomes e power root x times the derivative of u with respect to x is 1 over 2 root x. So we multiply this by 1 over 2 times of root x. And this can be written in another form also, that is e raised to the power of root x divided by 2 times of root x. And this is the derivative of y. In question 6, we have y equals e raised to the power of 2 cosine x plus e raised to the power of 2 sin x. And so we have to find the derivative of y, that is dy by dx. Here we are going to make two substitutions. That is, we are going to substitute 2 cosine x equal to u. So we write u equals 2 cosine x, and let's find its derivative, that is u prime. And this equals 2 times the derivative of cosine x is negative sine x. So 2 times negative sine x is negative 2 sine x. And for the next term, that is for 2 sine x, we replace or we make the substitution v. This equals 2 sine x. So therefore, it's a derivative v prime, and this equals 2 times the derivative of sine x is cosine x. So it is 2 cosine x. Now, after we made the substitution for 2 cosine x and 2 sin x, we can rewrite this y in terms of u and v. So therefore, this becomes y equals e power, replace 2 cosine x by u. So it is e power u plus replace 2 sin x by v. So this is e power v. Now we find its derivative with respect to x. So dy by dx equals the derivative of e power u with respect to x is e power u times the derivative of u with respect to x, that is u prime, plus the derivative of e power v is e power v times the derivative of v with respect to x, which is v prime. So we can now substitute the values of u prime, v, and v prime. And so this becomes e raised to the power of u is 2 cosine x times u prime is negative 2 sine x. So I multiply this by negative 2 sine x. We then have plus e power v. So we write e raised to the power of v is 2 sine x. So replace v by 2 sine x times v prime. So v prime is 2 cosine x. So multiply this by 2 cosine x. And since we observed that we have the common factor 2 in both terms, we can write this in factor form. Therefore, we write dy by dx. This equals, I'm factoring 2. When I do that, the first term, I just write this as a first term. That is cosine x times e raised to the power of 2 sine x. And then when I factor 2 from this term, we will have negative times sine x times e raised to the power of 2 cosine x. Close this bracket. Therefore, this is the derivative of y. Let's do question 7. Here we have y equals negative 4e raised to the power of sine x squared. So we can make the substitution u equals sine x quantity square, and this implies we can find its derivative, that is u prime, which is the derivative of u with respect to x. So first we apply the power rule of differentiation here, which means we put the 2 in front, and then sine x raised to the power of 1, which in fact is sine x. And then applying the chain rule, we multiply this with the derivative of sine x, which is cosine x. And this can be written in simple form as sine 2x. That is according to the double angle identity. Sine 2x equals 2 sine x cosine x. So therefore we rewrite 2 sine x cosine x equals sine 2x. That is u prime equals sine 2x. Now let's rewrite y after making the substitution for sine x quantity square. So therefore we have y equals negative 4e raised to the power of u. So let's differentiate both sides with respect to x. So this will be dy by dx, and this equals negative 4. The derivative of e power u is e power u times the derivative of u, which is u prime. Now let's do the back substitution for u. u is basically sine x quantity square. So this becomes negative 4 e raised to the power of sine x quantity square times the derivative of u, which is u prime, which is basically sine 2x. So we multiplied this by sine 2x. So let's write this as a negative 4 sine 2x times e raised to the power of sine x quantity square. And so this is the derivative of y, which is dy by dx. We now find the derivative of y equals e raised to the power of x secant x. Here we replace this x secant x by u. We are making this substitution for u equals x times secant x. So let's find its derivative, that is u prime. We differentiate both sides with respect to x. And here we have to use the product rule. So we can consider this as first and this as second. So I write the first, multiply this with the derivative of secant x, which is secant x, and multiplied by tangent x. Now we put the second term, that is secant x, and then multiply this with the derivative of x, which is 1. So u prime equals x times of secant x, or in fact we can factor the secant x, which we have in both terms. So I'm going to factor secant x and then write this as x times of tangent x plus 1. So this is the derivative of u. Now let's rewrite y after making the substitution. So y equals e raised to the power of u. Therefore, we find its derivative, that is dy by dx, and this equals e power u. Multiply this with the derivative of u, which is u prime. And so this becomes, now replace u by x secant x. So this becomes e raised to the power of x times of secant x times u prime, which is secant x times of x tan x plus 1. So we can write this as x times of secant x multiplied with, I'm sorry, it is secant x. It's not x secant x. So it is multiplied with secant x times x tangent x plus 1. So we can write this as dy by dx is equal, I'm going to put this in front, that is secant x times x tangent x plus 1 times e raised to the power of x, this is x secant x. And so this is the derivative of y.